Correlation using Pearson's product moment. Here we are going to measure the correlation between hours of study, which is represented by the letter H, and score, which is represented by the letter S, via a tool or method called Pearson's product moment. We will obtain a descriptive measure, which is a statistic with a value that will be between -1 and +1, inclusive, as indicated in the following scale. So if you get a correlation that is -1, that's perfect negative. If you get a value that is between -0.5 and -1, that's strong negative. Then you have a weak negative correlation between 0 and -0.5. Then you have a weak positive between 0 and +0.5. You have a strong positive between 0.5 and 1, and a perfect positive. So you can never get a correlation which is outside of these boundaries, outside of -1 and 1. So here are the data values. Okay, it's not just any values, it's data values. We're going to calculate a data statistic, a descriptive measure called a value statistic called correlation. But here are the data values we are going to use to do that. Here outlined is the order of mathematical operations with a slight modification. B for brackets, as we know, E for exponents, M for multiply, D for divide. But S now, we're using S for subtract. And we are going to use sigma for sum. And as you can see, we purposefully put sigma for last because we want to emphasize that whenever you see sigma, do all the operations to the right of it first and leave sigma for last. Here is the R formula, the Pearson's product moment formula. And each term you can see sigma is present. So please, whenever you see sigma, do all what's to the right of sigma first and leave sigma for last. Here is a simplified version of the formula. A will be the first number, subtract the second number. That's n times the sum of xy minus the sum of x times the sum of y. That will give us A. B is the third number minus the fourth number. That is n times the sum of x squared minus the sum of x all squared. And C is the fifth number minus the sixth number, which is n times the sum of y squared minus the sum of y all squared. So this very long formula is simplified to R is equal to A over the square root of BC. So here's the setup that we did in Excel to facilitate this very lengthy calculation. And the first number we have to find is n times the sum of xy. So we need to find the xy first. So we have created a column called xy. And the first xy is, you type equal, and that would be A2. You click on A2 times B2. Click on B2 and you click enter. And to get the rest of the xy's, you go back to C2, go to the lower right-hand corner where the green square is, and you double click on the hole, and you drag, and these are all the xy's. And to find the sum thereof, you go to editing, and you look for auto sum, click on auto sum, type enter, and this is the sum of the xy's. So now we need to multiply this by n. N now is 7, because 7 individuals were interviewed. 1, 2, 3, 4, 5, 6, 7. So therefore now we go here and we type equal 7 times the sum of xy. The sum of xy is in C9. We click on C9, type enter, and here we have n times the sum of xy. That will give us our first number. To get the second number, we need to find the sum of x. So here we have our x's already. So all we do, you can even type for SUM in the sum function and double click, and you type, you indicate to Excel where you want this, which values you want to sum, and you type enter. And here is the sum of x. And to the sum of y, we can simply go to the lower right hand corner and drag this formula, and this will give us the sum of y. As you can see, the sum of B2 to B8. And here now we can calculate the sum of x times the sum of y by typing equal. Click on where the sum of x is, that's right there. Time, click on where the sum of y is, that's right there in B9. And this is the sum of x times the sum of y. Now we need the sum of x squared. So we have to find x squared first. So here we have a column called x squared. So we just type equal, and the first x is in A2. We type A2, on A2, and you just type raised to the power of 2, and this is our first x squared. 10 by 10 is 100. Then to get the rest of the x squareds, we double click on this little square and we drag, and this is all our x squareds. So now to find the sum, we just go to editing and we type auto sum, type enter, and this is the sum of x squareds is in 9. We have to multiply this by n, which is 7. So we have 7, type equal first, 7 times the sum of x squared is in D9, and we just click on D9, and this is n times the sum of x squared. This will give us our third number. Our fourth number is the sum of x all squared. So we type equal, and we look for where the sum of x is in A9. Click on A9, and then we type raised to the power of 2, and this will give us the sum of x all squared. Now we want n times the sum of y squared, so we need the y squareds. So we create a column called y squared. We go where y squared is, and we type equal, and our first y is in B2. We click on B2, and we type raised to the power of 2, and this is our first y squared. To get the next y squareds, all the rest of the y squareds, we double click on this green square, and we drag, and this will give us all the rest of our y squareds. And to find the sum thereof, we go to editing, auto sum, enter. These are the sum of y squared, this value there, and here we're going to find n times the sum of y squared equal 7 times 9. That's where the sum of y squared is, and this will give us n times the sum of y squared. Now our sixth number, we want to find the sum of y all squared. So we type equal, and we look for the sum of y. Here it is, and we're going to square this number. So we click on B9, and we type raised to the power of 2, enter, and this will give us the sum of y all squared. Now to find as we say, A is the first number, subtract the second number. So that will be B10. So we type on equal, that will be B10 minus B11, because that's where the first number and the second number respectively are located. Type enter, so this will give us A. B now is the third number minus the fourth number, and the third number is in B12. So B12 minus the fourth number is in B13. Click on B13, type enter, and C is equal to the fifth number, which is in B14, minus the sixth number, which is in B15, and we type enter, and what we message is calculate R. R is equal to A, which is in B10. You can put this in a bracket, type on B10, open bracket, divided by the square root. So we type SQRT, there's a square root function, double click on it, and square root of B times C. B is in D11 times C. C is in D12, sorry. Click on it, and then close bracket, and type enter, and this will give us our R. Now we can verify if this R is correct by using the inbuilt Pearson's formula in Excel. So to do that, we go to formulas, you go to insert function, make sure this is in statistical. So you have a variety, you have financial and so forth. Click on statistical, and you look for Pearson's. This is in alphabetical order, so you look for P. Here is Pearson's, and you click on Pearson, you click on OK, and Excel will ask you which is the first array of numbers. So we're looking at A2 to A8. These are the independent values. And the second array of numbers, the response data values, B2 to B8. And as you can see clearly, look, Excel has provided us with the answer, which verifies our R. So for our working, what we can do is to go to snipping tool, go to new, highlight the area that you would like to take a snapshot of, and then you paste it in your Word document. And now we are ready to conclude. We are ready to analyze this number, 0.98. This number is clearly between 0.5 and 1, very close to 1. So that's a strong positive correlation. 0.98 is a strong positive correlation. So therefore, according to these two samples of data values, that's hours of study and score, there is a strong positive correlation between hours of study and score. In other words, the more time you spend studying, the most likelihood that your score will increase.